let us continue to discuss continuous functions. So before defining what continuous functions are, let us look at one quick example and then develop some idea. So our f is a piecewise function, which is almost 2x. When your x is 1, it has value 0. So let me draw the graph quickly. So it's almost 2x, like this. When your value, x value 1, the function has value 0. So the graph of f looks like this. Okay. This function is not continuous. I mean, the graph is not continuous because the graph is broken at x equals 1. So the graph is not continuous. However, we can redefine f to get a function g so that its graph has no break. Well, simply you move this point to fill this hole. Then we will get a new function g. So we are filling this point to have continuous function like this. Well, we can declare the function value is exactly the value so that this point is on the line y equals 2x. So namely, this is 2. So we define g has value 2 when your x equals 1, and then 2x otherwise. Well, this is simply y equals 2x. So we can redefine this function to have continuous function like this. So the idea is we can draw the graph of this function without lifting a pen, without lifting a pen. So when you draw graph without lifting a pen, we can say the function is continuous. Actually, this is old timers definition. So this is a kind of old definition of continuous function. Let me write down one more observation. So we want to define continuity in terms of limit. Well, here, when you take limit of g as x approaches 1, well, this limit is 2, of course. But the point is, this happens to be value of g when your x is 1. So this is true for g, but not for f. The limit of f is 2, but the function value f of 1 is not 2. So we can use this observation to define the continuity in the next slide. Okay, so we define continuity in terms of limit. A function f is continuous at x equals a if the limit of f is exactly the value f of a when your x approaches a. So this definition defines continuous function. Well, this is very nice property in a sense that if your function is continuous, finding limit is just easy. You just plug in. Equivalently, this continuity asks three things. First, f of a must be defined. When you compare two one-side limits, well, two one-side limits must agree. And this limit must be the function value f of a. So then, once your function satisfies all three conditions, you can say the function is continuous at x equals a.